Okay, hello everyone. Welcome to part 2 of implementing a logical puzzle solver. My intention this time is to basically do tidy up work. The the code that we implemented last time left me more than a little unhappy the following morning, mostly centered around the raw access that the logical steps had to various parts of the underlying puzzle data. So today I'd like to implement some abstractions around that. It's not going to be a long stream. I needed to get it done, and I was getting to the point of wanting to do it before the next time I could stream, so I'd rather get it done together. So if we pull up the code from where we were before, I'll kind of show you what I mean. Okay, so at the moment, if we look at symbol here, then symbol choice is giving back U sizes, basically. So it's giving back the indexes of the symbols in question. And that's just, it's not great. And completely understandable from a raw data manipulation perspective, but it's not great from the perspective of giving back something that the logical steps should be dealing with. Ideally, from the moment we're outside of the puzzle data type itself, we should only ever be dealing in IDs of things rather than in sort of U sizes and the like. So what I want to do is I want to first of all deal with some of the warnings. So symbol set, for example, has a name that's never read. We're going to have a little look at something that we might want to do for that. And then we're going to try to basically make it so that symbol IDs and probably symbol set IDs are the only thing that things from outside the puzzle have access to. And so that when you, for example, retrieve a symbol from a symbol set, we ended up, let me find it now, we end up passing in the set's index into the symbol set in order to achieve that. And while that's fine at a raw level, it's really not great at the level that we would like our logical solving code to be dealing with. Because if I pop over to singles.rs, then yeah, if we look at naked single here, set is a U size. Symbol choice requires us to pass in, we pass in the cell index, and then we have to say, give me the nth symbol set out of that. And this is just all unpleasant, where if we could wrapper all of this stuff up through the puzzle, or possibly through a data type that wrappers up the concept of you having a borrow puzzle and a borrow mute board, then we could possibly get a bit further with the whole thing. So that's the intention for today. And the first step along this line is to abstract away set indices to give you something like a symbol set ID. So that's my intention. And let's get going. So the first thing I'm going to do is I'm going to say that symbol set here, I'm probably going to make a symbol set. I'm going to call it a raw symbol set. And where are we now? Symbol choice. I'm going to make a raw symbol choice. And the reason for this is because those data types are going to be I mean, at the moment they're spread throughout. You know, if we look at puzzle, we can see now, if I search for raw, all sorts of places where raw symbol sets form interfaces to things like in board and so on. And I want to get rid of that. I want to get us to the point that you never ever encounter a raw thing outside of here. So if we look in here, we can see that choice is a raw symbol choice here. And I don't want that. It's ugly and nasty and takes away from what I'm hopefully going to get towards. So let's keep going. Puzzle is probably where I need to implement this interface. So in our puzzle code here, we already have region index and we have cell index, and those give us give us entries into the puzzle for that. So let's have symbol cell index. So that's going to be debug, clone, and copy, and transparent. Symbol set index. And what this is going to allow us to do is allow us to reference these things from the outside world. So let's find somewhere that returns a usize or takes an nth, how many symbol sets do you have and stuff like that. And let's get to a point that we're returning only symbol set indexes. So printboard, no, add constraint, no. So symbol set takes an index and returns a raw symbol set. So it shouldn't take an index of a usize. It should take an index, which is a symbol set index. And that's going to be that. And that doesn't sound like much, but just by making this transformation, we're going to get ourselves a bit protected. And then we can do better later. Anywhere else that's taking a usize here, all cells. Symbol set gives us an iterator of usizes. It's going to give us an iterator of symbol set index. And anywhere else, logical steps, blah, 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 solve a board. Okay, so this is going to break our constraints. So let's go and fix those first of all. So prep board is saying, okay, I want the digits, and it's assuming it's going to be set 0. So we're actually going to take a step and solve. Let me find it. Come on, where is it now? Let's just get rid of that because we don't need it. So raw symbol set has a name which is not used anywhere, and we're going to fix that at the same time as fixing this, because we're going to register the symbol set for the digits with a name, and then we're going to look that symbol set up by name. So here at the moment in our new Sudoku code, we're creating the symbol set with the name digits. So that's what we're going to look up. But we're going to be reasonable about this, and we're going to create a top level module, which can be fully public, why not? And we're going to call that one, I'm going to give it the really, really brilliant name of consts for now, just because it's going to contain a bunch of constants that we care about. Constants for Kaji. And we're going to have a const. What we'll call it, symbol set digits. Which is that, and it's going to be public. It's going to be the digits, numerical symbols found in a puzzle. These are likely to be 1 through 9 or similar, but could equally well be -4 through 4. 0 to 9, etc. So our goal there is just, if these are digits and would have therefore numeric value, then we'll register a symbol set with that name. So given that, let's pop over to puzzle, and instead of registering it like that, let's register it with symbol set digits, because that means that we definitely know it's there. And let's change this so that instead of calling symbols 0, we're going to call symbol set by name, and we are going to give it the name symbol set digits. Now we have to complete this operation, and we can complete this operation with in puzzle then symbols. So symbols, it was symbols, not symbol sets. So it's symbols by set name. That's effectively the function we want to create. So let's write that, pubfn symbols by set name. Iterator item equals symbol ID. Okay, so we've got the name of the set, so we need to find that set. Let's think what the best way to do this is. I'm going to create an Can I create an empty set? No, because the whole point of this is that the types are always the same. Okay, so we have to get the set index, and if the set doesn't exist by name, then we're going to we're going to end up aborting, but that's okay. So this is going to be an internal function, symbol set by name. Actually, it may not be an internal function. Let's make it public. So this is going to return a raw symbol set for now. Eventually, no public function should return a raw something. So we'll get there. So this is going to be what generates the symbol set. And then here, we're going to go self.symbol set by name set to IDs. And we need that. Thing is, we need the set index. So let's do this internally, actually. So this is going to be symbol set index by name. Again, this is all because at the moment we have these raw sets. We can tidy this up later. Let's leave that as to do. And here it's going to be self.let set equals self symbol set index by name set, and then self.symbols set dot to IDs set. And now we just need to implement set index by name for set for index set in self raw set in self dot symbols dot iter dot enumerate if raw set dot name is equal to set, return index, and if we get all the way out to here, panic, unable to find set. This is going to complain that this function doesn't exist. So let's generate that method. This is going to return a borrow str, and that's just going to be self.name. So we fixed given digit. Given digit now behaves exactly as before. Singles, on the other hand, is going to be more complicated because it's dealing with raw symbol choices and all of that joy. So board.choices nth set is expecting a usize, and it found a symbol set index and all of this joy. So we're actually going to have to fix up quite a few little bits here. Let's just see how much. So choice set, symbol set, board choices. Okay. Right. How are we going to fix this? So we've got two options here. One is that we could say that boards always have a puzzle reference in them because you're always solving a board for a puzzle. And since puzzles are immutable from the point that the solve begins, that's acceptable. Certainly in the future, if we want to store sort of partial deductions, we're going to store them in the board data structure rather than anywhere else. We want board to be cheap to clone, but we also need it to be full. I think I prefer that, because then we can change the logical step API to just take the board. Is that going to work? No, I don't like that. What we're going to do instead, and again, this API may change over time, and I'm deliberately showing you all of this because this is me thinking things through. I'm going to create a type which contains a borrow puzzle and a borrow mute board, and is going to basically be the way that we pass stuff into these logical steps. And it's going to have an API that the logical steps will use, and all of that API can wrapper up the raw stuff so that you never have to see these raw data types outside of the puzzle module. So let's make that and see what it looks like. So this is going to be a representation of an in-progress solve. Struct. What are we going to call this? Solve state, which takes a tick puzzle and a tick board. And so we have puzzle, which is a borrow tick P puzzle, and a board, which is a borrow tick B mute board. Note that the solve state itself doesn't need to be mute. It contains a mute borrow. I think that's going to work. So that's solve state. So now let's implement for solve state. So impl for puzzle and board. Solve state for puzzle and board. So we're going to take a new, which takes a puzzle tick P puzzle and a board tick B mute board, and gives back a self, and we can go self puzzle board. So far so good. Let's find out what the situation is with solve state. Let's make main do that, and we're just going to work backwards until we've fixed all the bugs. Yeah. So main creates a puzzle and then does let board equal puzzle.solve, and it gets a board back. Okay, so the solve interface to puzzle is what's going to deal with all of this. So let's jump into there. So solve gets a board and does logical steps. Instead of just getting a board and then going, we're going to go let solver equals solve state new self and a borrow mute board. So that gets us our solver, and then we're going to pass the solver into the logical steps. So let's go and find constraint.rs. Let's grab solve state out of there. It needs to be a pub struct. And then, so prepping a board takes puzzle and a board. Can it take a solve state instead? Prepare a board for playing, called exactly once, used to apply constraint information to the initial board created during solving. If the constraint has no preparation to do this, can be omitted. Yes, this can take. Hang on, does it take a borrow mute puzzle? No. So this can take a state, which is a solve state. And this can take a state, which is a solve state. So we're getting somewhere with this. Obviously, you know, we're going to keep buzzing through until we get there. So initial board is supposed to return a board. It's actually going to return. So a solve state is actually going to have to own the board rather than borrowing it, because otherwise bad things will happen. So we can just go and do that now. Solve state does not need a tick B. It's going to just have a board. So initial board, get board, prep board. Yeah. So let's call that one solve state. actually, let's just call it state. And this is going to be solve state new on self and the board. So we don't need the tick B. It's all about learning these things, see? And that takes a whole board. So we're getting somewhere. Prep board doesn't need to take self because it's taking a borrow mute state. Taking a borrow mute state or a borrow state? It's got to be able to mutate the board, so it's got to take a borrow mute state. So let's put that in. And here as well, because it's got to be able to mutate the board. So puzzle, let's keep going. Logical step shouldn't take a board. It should take a solve state. And it doesn't need to pass self in there. And this now is going to need to forward the solved method. We can fix that in a bit. Solve has got its solve state, so that's all good. And it's expecting to return board, so we're going to want to do like an into board at the end there. So we've got two methods that aren't implemented, solved and into board. Let's put those in. Solved, which is going to be that, and into board, which consumes self and gives back a board, and it's just that. So that's sorted out puzzle. Now, obviously, every step within these constraints, we're going to have to implement the forwarding methods, and so as we do, we will probably start to implement some extra wrapper types so that we never ever see a raw something in one of these constraints. So let's do given digits. So given digits doesn't get a puzzle and a board. It gets a state, which is a borrow mute. Solve state. And it's going to immediately complain that, you know, it can't do these things. That's going to be state. That's going to be state. That's going to be state. And we won't need to pass the board in. Oopsie. We can import. And so now we know the set of methods that we need. So symbol set by name. For now, I'm just going to forward all of these methods on directly, and then we'll worry about what's going on. So that's returning a raw symbol set. And it's going to be self.puzzle.symbol set by set name. Why did that do that? So that should just be set. Mismatch types expected a raw symbol set, found an iterator over symbols. Oh, it's symbols by set name. Nah. So that returns an impl iterator item equals symbol ID. Why have I got parentheses there? Right, so that's done the symbol set by name. So cell at, we can pass through again, and set symbol we can pass through. Those are probably the easiest ones to do. So cell at is going to return a cell index, and it's self.puzzle.cell at row and column. And set symbol takes a cell index and a symbol ID. Let's just do that like this. What does set symbol need to return? Probably nothing. Self.puzzle.set symbol. Borrow mute self.board. Cell and digit. And that therefore is going to have to take a borrow mute self. Right, so we fixed up given digit, and that's just forwarding things through. And interestingly, It's taking a name, it's returning symbol IDs, it's taking rows and columns, it's returning cell indexes, and it's taking cell indexes and symbol IDs. So none of that is dealing in raw objects. So that's good. Single. That is going to take a state, which is a borrow, mute, solve state. And now we have, once again, a whole bunch of stuff that we have to forward. So step one is, let's just, whoopsie, take that and say, okay, that's definitely state, that's definitely state. State, won't need to take board, state, and state. So we get to tidy all of this up based on what we've worked out. So all cells is just going to forward all cells. And I think that's fine. It's going to be an impl iterator item equals cell index. And it's going to be self.puzzle.all cells. Nice and easy. Just going to close out all of the files that we don't need temporarily so that I can focus a bit better. Symbol sets is next. So again, for now, plain forwarder. That looks remarkably like it would just be an impl iterator. Item equals symbol set index. And I might end up renaming that to symbol set ID, but we'll see. Self.puzzle.symbol sets. Right, choices is an interesting one because choices gets you the all of the choices for a given cell, where realistically what we want to say is we want to say, I want the choices for this cell's this set. So I'm going to pass set in there as well. And I'm going to control.that, generate the choices method. And I'm going to call this a symbol choice. And this is going to wrap the raw symbol choice and the set index so that everything that gets returned from it, if you iterate it, gives you symbol IDs and so on, despite the fact that nominally it's all usizes inside. Okay. Whew. So what we need to do first is we need to say raw choice is self.board.choices given the cell.nth set.0. And that has to be an option symbol choice. Yes, because that's saying it can unwrap it, but in theory the board may not have a cell at that index. So no, because the unwrap is just for the nth, and we know that it will have one. So we can stick the unwrap there and get rid of the option there. In fact, let's make that unwrap something more pleasant. Let's say expect for some reason a choice was missing. Okay, so we have a raw choice and we're going to wrap that up into something that can take the symbol set index and then have all of the relevant methods on it. So we're going to say symbol choice new of raw choice and the set. So now we need to define a symbol choice type, and we're deliberately defining that type in here because we don't want it to be part of the internal API for symbols. In fact, I'm going to ultimately hopefully hide the symbols module entirely. So symbol choice has a set, which is a symbol set index, And it has a choice, which is a raw symbol choice. Ooh. No, that's fine. We can have a symbol choice mute or something like that later for other things. Yeah, we'll work out what we work out when we work it out. Import symbol choice. Pub fn new. So this is taking the symbol set index and the raw symbol choice. I'll call that one choice. So set and choice. So this is now returning the data type that we care about. Choices takes 2 arguments, 1 argument was given. Have I fluffed that? No, I'm just... Okay, so if not choice.solved. So we need to forward solved. Again, this is all fine. We're deliberately introducing all of this API, even though in theory we don't need to. So let's do that now. Pub fn solved, which takes borrow self, returns a boolean, and it's just going to be self.choice.solved. I mean, in theory, I could forward down to the symbol for these methods with deref, but I don't want to because I don't really want raw symbol choice to ever be exposed if I can avoid it. Single value is option usize, I think. So let's do that one. Pub fn single value. But we're not going to return an option usize. We're going to return an option symbol ID. So let raw equals self.choice.single value. So self.choice.single value is that, and we're going to do that. Dot map given a symbol. We're going to return a symbol ID. New. This one, yeah, new. Passing it the set and the symbol. And it's going to say new is private because we didn't want symbol ID new to be exposed to things. And why didn't we want that? Because fairly obviously, I'm going to put that as pub crate for now. But eventually, I'm going to fix that up. I'm going to move symbols underneath puzzle and we'll do pub super or something like that for that one. For now, though, we can see that we've got a symbol ID here, which is what we wanted. So now we're doing state.setSymbol cell puzzles.symbolset.id set value. Well, we don't need that computation now because we have a full symbol ID. So that's just value because it's a full... It's just a full thing. And set symbol. Did we implement that? No. So why is that not failing? State.setSymbol. Solve state.setSymbol. Oh, it's solve state.setSymbol and we've already done that forwarding. Yes, because it was symbol choice that I was just working on. That makes sense. Okay. Get rid of symbols for a sec. So here we're saying, give me the cell information for this cell. And then we're saying, give me the value for this cell. And then we report it. So cell information, easy enough. We can do that one. Generate that method. That's going to return a borrow cell info, and it's going to be self.puzzle.cell info for cell. So that one's nice and easy. It doesn't need to be pub crate though, that can be pub. Let's count the choices method here. symbol set, no method named symbol set found. Okay, so symbol set is returning a symbol set object, and then we're saying, given this value, I want to know, you know, what is the value here, which is, that's going to be a symbol. So actually what we want here is not state symbol set. What we want is symbol. So we're just literally going to call that symbol, and we're going to pass it the symbol ID and expect that to give us back the borrow symbol. So let's generate that, and that's going to be a borrow symbol. And so we can do self.puzzle symbol set, which takes a symbol set index. Oh yes, we started to tidy up that API, and perhaps we shouldn't have. Let's leave that as to do for now, and finish what's going on in here, and then we'll come back to it. So logical step here doesn't take a puzzle and a board, it just takes a state. And then we get to fix this a little bit. So regions, region, symbol sets. Okay, so we're starting to get somewhere, and then that's going to be board. That's going to be state dot. Is it not choice set? What did we just did that, didn't we? No, because the whole point of hidden singles is that we're adjusting the choice rather than setting the cell directly. Because we do the hidden symbol, we get the choice set, and then if that's functional, we move on. So that's going to take a cell and a symbol set index. That's fine. Let's keep going. Let's just, for now, tidy up, and then we'll go from there. So that's the state, cell info, that's the region again. And this is getting the cell, sorry, getting the symbol, which we literally have just decided is called symbol. So this is going to be state.symbol for, which one did we go for? Symbol. Because that's the symbol ID that we've come up with. Right. Okay. And that doesn't need to be a borrow, because why would it? And does that match what we set up here? I mean, we don't need that borrow. Yeah. Okay. So we need to implement regions. Again, for now, this is just going to be an import iterator. Item equals region index. Puzzle regions. You know, we're just forwarding things through, because I really don't want to be cleverer than that at this point while we're refactoring this code. So region takes a region and it's going to return it. So let's do that. That's going to return a borrow region. And let's go self.puzzle.region. Again, we could deref this thing to puzzle, but would we deref to puzzle or to board? I'd rather build up the API that we're expecting solvers to use this way. So n symbols is because symbol set, given a set index, returns the borrow symbol set. So let's do that. That's a borrow symbol set, but it's a raw symbol set. We'll be worrying about that in a moment. Self.puzzle.symbol set. And again, I mean, I'm okay with all of this for now, but we're going to get to a point when we've done this refactor. So choice set. This is actually just getting the choice for the cell for this given symbol set. Do we already have a function for that? In here, we have choices, which returns a symbol choice, which is a raw symbol choice and the symbol set index for the given set. So that is what we're after here. So that is just choices. And then options is what's giving us the iterator to tell us the symbols. Now, we're using that to index a symbols array. Which isn't great because that's... But we're just using that to index into here. So that's okay because we're not ascribing any meaning to that. I just don't like it. I'm going to allow it, but I'm going to explicitly be a bit grumpy, at least in the short term. We'll work out what we want to do later. So for now, let's just forward that through. So that's going to be an impl iterator item equals symbol ID. And it's self.choice.options. Map given the value symbol ID new self.set comma v. Wow, what's going on here? That's going to complain that there's a captured lifetime. So let's do let set equals self.set.0. That's now a usize, which means I can put set there and I can say move that in, and that's happy. But now, of course, this is unhappy because it doesn't really know what's going on here. So symbol ID is going to need like a symbol number or a symbol index or something like that. So let's go ahead and implement that. So we're going to have to pop back to symbols for now. Symbol ID has an into parts. So we're going to have a pub fn symbol index, which returns a usize, and I don't really have any hope of doing anything nicer than that for now, but that's okay because you're never going to be able to use that usize for anything other than it's this index within this set. So symbols symbol number dot symbol index. There we go. And then here we're creating somehow that symbol set given that item. Well, we don't want to allow that. So what we're actually going to have to do instead is store those symbol IDs as well as the indices. So let's capture that right now by saying that we want to capture those symbols. So symbols by set name. No, symbols for set. And let's go ahead and get that. So this is, so symbols by set name, wherever that was, does self.puzzles.symbols by set name set. And that's returning an impl iterator symbol ID. So let's grab that as well. So that's going to be self.puzzle. Symbol set for set dot to IDs set dot 0, and I hate doing that for now, but that's what we've got. So that's an impl iterator, so that's going to be a collect as a vector, which will give us a vector. Now at this point I don't need to get the len from there because I can do that as symbols.len, and then in fact we can get rid of that, and just anywhere we see n symbols we can replace that with symbols.len. Right. So at this point, rather than saying symbol set blah 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 to get a symbol ID, the symbol that we've got is from symbols IDX. I think. Let me just double check. Yeah. Symbols IDX. That's going to be symbol IDs. And that's going to be symbol IDs. Right. And then that refactors everything. So in theory, everything works except for any to-dos that we have left. Is that the only one? It's the only one. And its purpose is, given a symbol ID, we want to retrieve the symbol. So we're going to need the set. So we're going to go let do I have a set for? Set symbol, no. Solve symbol set, symbol set index. Set index by name, symbol sets, symbols. Blech. I'm just going to break it down for now. Let set, comma, index, value dot into parts. And then we're just going to be absolutely hideous here, and we're just going to cheat. So we're going to go self.puzzle.set. Self.puzzle.symbols set dot index, borrow it. Yeah, so that gets us to, in theory, let's just double check. I mean, in theory that will run. Let's find out just how broken we are. Oopsie, what have I done? That's what I've done. Does this still solve? So it does. So we haven't completely broken it, and we've introduced some abstractions, which was basically what I wanted to do at this point. I mean, it's a hideous set of abstractions, but it's there, and it means that we can now come out of those and we can go to our constraints. And our constraints no longer interface to boards or puzzles. And while there's an amount of raw present in here, I believe, let's just double check. Let's get rid of board and let's get rid of puzzle. Let's just very quickly scroll through here and see if we see any raw types. No raw types there. No raw types there. So we've got rid basically of access to the raw types, which is kind of what I wanted to do. So let's just complete this refactor and tidy up any of the remaining things. So constraint no longer deals in boards and puzzles, it only deals in solve states. puzzle itself, what are we doing? Right, well, we don't need stead usize. Row and column are never read. Cell info. I'm not going to worry about that one for now. End cells is never read. Debug. Yep. Okay, so all of the warnings that are left or lints that are left are because there are fields that we haven't actually put to use yet. Excellent. So let's so this is a rework. Tidy the solver API to make more explicit. This is the first step in. And eventually we're going to improve this some more, but you know, that's our first step. So we'll push that. And let's think about what the next step is that we want to achieve. I don't want to go crazy at the moment, but maybe we could move the symbols or improve how public or not they are. Or we could move the constraints into another crate, and then we can be really explicit about what the constraints have access to. I'm going to do that. So let's do that refactoring. Okay. So we're going to go cargo, new, lib, Kaji constraints, Kaji rules. So eventually these things are going to be rules, which means that they're going to be able to take some sort of puzzle state and build up the puzzle data structure that we need. So they'll need like an interface to puzzle that can do that kind of thing. And at that point, we want to make damned sure that it doesn't have raw access to things it shouldn't have access to, which is why I think putting in a separate crate is a good idea. So let's call it Kaji rules. And let's check cargo.toml. Perfect. So we have this new crate, which is Kaji rules. And what we want to do in here is we're going to move the actual constraints over. And we'll end up calling them rules because constraints are just part of rules. So let's say pub mod constraints. This is going to be all a little weird for a moment. I'm going to get rid of mod constraints from there. And I'm going to git merv Kaji source constraints.rs to Kaji rules source. And I'm going to get merv so that in Kaji we've got consts and lib and puzzle and symbols, which is like the core solver stuff. And in Kaji rules, we have the new constraints. Now, the constraints are going to have to depend on Kaji. Now the rules compile. Shocking. And let's see what's going on in puzzle. So what does this have? Why is that importing stuff from constraints? It's importing stuff from constraints because the actual constraint trait needs to live in Kaji. So let's fix that. Lib pub mod constraint, actually pub crate mod constraints. Let's create that. Let's go. This is this slot and is going to come into here. So what's going on now is that needs to come from there. Now what are we missing? So logical step is missing. That gets pulled in. So puzzle is semi-fixed. We've got those things. We've got this symbol function is never used. Well then, we might be able to get rid of it. Let's not worry about that for now. So here, we're just exposing the constraints. And did I have some code in there? No, I didn't. So that's all good. That's all good. Now at this point, these constraints are going to start failing because it shouldn't be crate puzzle. It should be Kaji. And that should be Kaji. And now in here, we're going to pub use constraints constraint, and we're going to pub use constraints logical step. So that comes from Kaji. And in fact, all of those come from Kaji. The module puzzle is a private module, so we're going to, like we've got pub use that, we're going to pub use puzzle solve state. And I'm going to stick constraint in there because it's ugly otherwise. It's a given digit now. Fine. So we've got that. We're also going to need solve state. And we'll work out what we're missing. So what we are missing is that symbol function that I said we'd have to work out if we needed it or not. Well, apparently we need it. So that becomes that. And then what are we missing here? So cell index is not exposed. So let's get that exported. So let's export that. And now we can import that. And that's all compiling. And now Kaji bin also needs Kaji rules. And it's not Kaji constraints given digits. It's going to be Kaji rules constraints given digits. And I'm not going to move them into the top level because actually we're going to have rules and we're going to have constraints. They're going to be different things eventually. So again, that builds and runs and we're good. So rework again, migrate constraints into new Kaji rules. Great. The intent here is to ensure that we know exactly the API in use, since we can now restrict APIs so that they are pub crate inside the Kaji crate. To know that constraints and rules will be unable to peek inside of symbols, etc. So that was the second major refactor that I wanted to do. Let's push that up as well. So any of you following at home can check that. So the next tidy up that we want to do. I mean, really realistically, the next thing that I want to do is I want to make it so that we're not calling functions we don't need to on those constraints. But I think that that's a functionality change, which I don't really want to implement yet. What I think is probably going to be of much more value to implement will be to break out the construction of the board. I don't really want to do that now because my intention is to stop streaming in no more than half an hour from now because some friends of mine are streaming and I don't want to miss their stream. So let's just pop back to here and make a call about these. So the row and column in cell information are never used. I mean, that's true. We never really care about that stuff. We only ever map from row column to cell index. We don't map back the other way, so I'm not going to worry about that for now. And that is fine. N cells for a board. Why would we ever need that? Oh, it's because we calculate indices. Certainly we multiply by n symbols. Do we ever multiply by n cells? I don't really think we do, so I'm not going to do that. It's an easy enough to compute value if we need it. So that's one tiny little cleanup. And let's try another thing. I want to make board pub crate and see whether that actually breaks anything. Yes. So it breaks the fact that that returns a board object. So that's fine. We don't get to do that. But if we look at import board, how much of this can we make either private or pub crate? So if I get rid of pub at all unsolved, no problem. Choice is no problem. Choice. That now becomes, actually, we don't use this function. Choice set, nothing. Let me just double check that this is, yep, never used. So I'm just going to get rid of it. My theory here is that all of these API functions are pretty lightweight. If it turns out we need it later, we can trivially re-add it. But all of a sudden, board doesn't have anything public that it doesn't need, because it's effectively an opaque data type. And in fact, one thing that might be fun is I'm going to grab a browser window and I'm going to pop that across here. And I'm going to cargo doc dash all dash node deps open. And let's pop that up. So we can see here that these are the modules and these are the data types. And in fact, board doesn't even exist as a data type that it gets to do. Print board we can probably eventually get rid of. I mean, if we returned a solve state rather than anything else, then we could actually operate entirely on a solve state and print that. Solve returns a board, and it's just a data type. There's no information about it. Because it's not interesting to Kaji. So it's not documented. We can probably improve that. So if I find struct board, because it is public, we can export it from here just because we might eventually have some public members on it. So let's just do that and reload here. So now we have a board which we can go in and look at, and we can see that it imports debug because that might be potentially interesting to people. But otherwise, there's no methods on it. It's just an opaque data structure that Puzzle can print out. So Puzzle can solve and generate a board, and it can print a board. And that's it. Now, a lot of these methods on Puzzle we can probably get rid of because they shouldn't really exist outside of the crate. So let's continue to try to extract things and to simplify. So let's pop back to Puzzle and let's have a look at all of these data types. So Puzzle definitely should be public. Actually, let's do some really, really big chunky things first. So constants, there, fine, board, cell, puzzle, solve state, logical step. Right. So this is all of the explicitly exported content. Note that there's no like raw blah state or anything like that, which means we should be able to come in here. Symbol, that's going to be exported because, or when we said symbol info is exported, so symbol probably doesn't need to be. So let's restrict that to the crate and check that nothing breaks. Create private symbols in a public interface. Can't leak create private types. So raw symbol set can also be create. Now that's upset singles, because now all of a sudden a thing that we thought we had, we don't. And that's fine, because the thing about raw symbol set is it has APIs that take set numbers. And I don't like the fact that it has APIs that take set numbers. I want those to be hidden away by something that we can cleanly export. And the thing that we can cleanly export comes from this, because this has the symbol set index. So let's actually get this done. So here we're going to have a pub struct symbol set, and it's going to have a symbol set index, and it's going to have, actually, what are we missing if we come and have a look at singles? So state.symbol says symbol is a private type, so you can't have symbol. That's interesting, because I thought I'd said that okay, no, because we're returning symbols to things that might want to think about them. Okay, yeah, we can't make that private, but we can make raw symbol set private because that didn't get exported. Okay, I'm saying private, I mean within. So symbol ID gets exported. Raw symbol choice should not be anywhere that's not pub crate. And so here, let's just double check. So if we do pub use symbols star, pub use puzzle star, I mean, it's hideous and we should never do that. But what it will do is it will force us to have a look at everything that's exported and decide whether or not we want it to be exported. So option iter, that definitely shouldn't be exported. So we can make that pub crate. Cell index and cell info, they're fine. Puzzle's fine. Region index is fine. Solve state's fine. Symbol choice, symbol ID, and symbol set index. Yeah, so it's only option iter there that needs to be privatized, as it were. So let's do that. And then we can get rid of these typed exports and just re-export everything. Because frankly, re-exporting everything at the top level probably makes sense, other than the consts, because all of these data types are useful. And I don't really see the value in keeping the module structure in what we export. So I said that option iter did not need to be public. And it indeed doesn't. So let's just double check that again. And right, so board, cell index, cell info, puzzle. That's all good. Kaji rules just exports the 3 rule types that we have. Kaji bin doesn't have any exports. We're going to have to write documentation for all of these, but I'm not going to do that today because I don't have enough time. Let's just fix these things here. So symbols references symbol set, which obviously has no name, and puzzle has no name because we moved that data type. So let's fix those. So cells can ultimately only have one symbol present in them per. Tell you what, should I do an import? No. I'm going to Hadoop that and Hadoop that, and then I'm going to go symbol set is create symbol set, and puzzle is create puzzle. Let's see whether I can format it like that. No item named that. Warning to escape. Those things do these. Yeah. Perhaps I can do it like that. I'm just not sure if Rust doc allows for breaking these things out. I don't think it does. So if I do that there, symbol set exported? No. So per symbol set index. See, this is part of the thing, you see? And this... I'm going to do it like this, but I don't like it. So there we go. So now we have a whole bunch of warnings that we need to finish cleaning up, which we can do. So those are never used. Here we go. Right, so symbols raw symbol set is more private than the item symbol underscore set. That's fair. Let's creatify that. Raw symbol set is more private than solve state symbol set. I mean, it is. We using that anymore? Apparently not. What's the type here? Raw symbol choice is more whatsity, so that's pub crate. We're getting there. We've got 3 warnings left. Those 2 and one somewhere down here. No. Down here. Which is that this method is never used. So we can get rid of it. Excellent. That was a whole bunch of tidying. Let's regen the docs. And let's refresh here. So board has basically no API. Puzzle has a whole bunch of API that we can get rid of. Rules might need to be able to access the regions, so we'll leave those in. It needs to be able, they need to be able to add inferences. We'll leave that in. They don't need to be able to acquire an initial board. They don't need to be able to logical step. They just need to be able to solve. And solve eventually we're going to return like a solve output rather than just a board, but there we go. And at that point we can probably get rid of print board, but for now we need to leave that in. And they need to leave add constraint in, but all of symbols, yes, because constraints might need to be able to retrieve symbols, but they don't need to be able to set symbols. They don't need to be able to propagate changes. So there's a whole bunch of stuff that we can get rid of. So impl puzzle. Let's have a look. Regions we said we wanted to leave. Add inference we want to leave. Initial board does not need to be public. Print board can be. Add constraint should be. I mean, does symbol set need to be anything other than private? No. Cell at. Given a row and a column, get a cell index. Yes. Symbols. Yes. Set symbol. No, that does not need to be public. Propagate changes does not need to be public. All cells, sure. Symbol sets, sure. Cell info, yes. Logical step, no. Solve, yes. Right. So that's, again, needs documentation, but it's a much cleaner API. Nothing particularly surprising there. That was puzzle. Board we said was empty. Cell index. It has nothing of note. Cell info has nothing of note. Region has 2 cells, which gives you a cell index. That's important. Solve state. This all needs to be public because this is how the solvers interact. Symbol. You can create new symbols if you want to register new symbol sets. That's important for rules. Symbol choice. That's all you need at the moment for that. Symbol ID. Fine. Symbol set index. Fine. Logical step and constraint are API types anyway. So we're getting a lot closer. Let's just have a little look at that. So this is, we now want to get rid of our careful imports because there's no point in them. What we can do instead is just everything most users of the crate need is just all of those exports. So rework to minimize exports. And let's think, what's the last thing that's probably worth doing today? Because we've not got a lot of time left. I'm going to rename region index and symbol set index to region ID and symbol set ID because realistically, we shouldn't be thinking of them as indexes. We should be thinking of them as IDs. So that should be region ID, and that should be symbol set ID. And amazingly enough, I don't need to fix up anything else because we just let the compiler do the right thing. Right, that's all the refactoring that I want to do for today. Just for reference, we do still solve our test puzzle. And next time, I'm hopefully going to introduce the concept of rules so that we can write a Sudoku rule, which is the thing that's actually going to create the rows and columns and cells and regions and so on, so that we are in a situation that puzzle new from new Sudoku doesn't exist. Instead, it's a puzzle new, and then we're adding a Sudoku rule, or yeah, so there'll be a Sudoku rule that will then add all of the state to the puzzle for us. So that's it for now. Thank you very much if you have been watching, and I will see you next time.